Hi everyone, welcome to 7Peak Speaks. Yeah, so if you want, the last time we have a webinar 3 months ago, yeah, we are back here. So we bring with the very interesting topics here. So first of all, I would like to introduce a little bit about 7Peak Software for those who have no idea who we are. So we are like a software and design agency based in Thailand. And right now we have like an international team here working for our clients in Thailand and also international clients. So what we are doing here, we develop, like enterprise solutions, website, web design, web application, mobile application for both iOS and Android. And we also do meetups, webinars organized in our office. The thing is that like we just want, people to have the knowledge, and also we share to back to the communities. Yeah, and also we always bring up to the upcoming interesting topics all the time. So today, know yourself app for your success. So this is our Node.js webinar, right? So yeah.
Yeah, and we have social media. So we have Facebook and LinkedIn. We always update and share event or our opportunity in there. So please click like and follow our social media.
Yeah. So we also sharing all the case studies sometimes, so people, if we are interested what we have done for our clients for the projects, yeah, you can also feel free to check out on our social media. And yeah, we work hard, pretty harder. So I just selected a few photos, like we have comedy trip and also outgoing in Bangkok around, and also we have an internal party. Yeah, we do have a lot of party inside. If someone who left to do some kind of activities, outgoing, yeah, we are the team. And we also did a lot of sports. Yeah, we have a lot of clubs the gymnastics, and also we have esports, gaming in the office, and also going out running in the park. Yeah, we have a lot of different clubs. Yeah. And yeah, we also eat a lot. We have a free lunch every Tuesday and Thursday, and with a different cuisine, of course. We have a 20 plus different nationalities. So yeah, we provide all the different cuisine for everybody. Yeah, and also we have a different class, a wine tasting class, and also other interesting class we bring into the office to to learn the new things, not only coding the whole day. Yeah, you can do something else. Right.
Yeah, and for now, we're looking for talent developer and design. We need more people. Yeah, such as head of mobile, web and cloud, front end and back end developer, and mobile, iOS and Android, UX UI designer, POPM, software QA engineer, and business development. If you're interested with us or have your friend looking for a job, you can contact us at job@7peaksoftware.com, or you can search for our website.
Yeah, or the website 7peak software/career. We put all the opening position on there. And not only that, you can also reach out to me. My name is Joseph, and also Pio. She also we are in the talent acquisition team. Yeah, you can feel free to reach out to us on the LinkedIn or any social media channel. If you're interested, just drop the message to us. All right, so today, we have a Node.js Meetup. We have 3 speakers today. So I just would like to invite our first speaker, Sebastien. So he will talk about the introduction about the Node.js, and also after that he will also discuss about the popular framework for the web server Node.js in the Express and Core. Yeah. So welcome, Sebastien. Are you ready? All right, so Sebastien is coming. Wait a second.
Hello. All right. Can you guys hear me now?
Yep, we hear you.
All right. Sorry, guys. So, well, my name is Sebastien. I have over 5 years of programming experience, mainly in the web. And I've mainly worked with Node.js and React. And I've joined 7Peaks a couple of months ago, actually this year. And for my presentation, I'd like to really make a really general introduction about Node.js and web frameworks for Node.js. So for the first part of my presentation, we'll be talking about what is Node.js, a little bit of history and its main features. And on the second part of my presentation, I'd like to talk about Express and Koa, two popular web frameworks for Node.js. And we will talk about some of their routing mechanisms, their middlewares, and error handling, and also we'll see their main differences. All right, so what is Node.js? Basically, Node.js is an open source and cross-platform JavaScript runtime environment. Okay, it runs with the V8 JavaScript engine from Google Chrome, so it allows JavaScript to run outside of the browser. Okay, and it comes with NPM, which is a package manager for JavaScript, and it has helped the ecosystem of Node.js proliferate, and it hosts today over 1.3 million open source packages that you can freely use. Right, so a little bit of history. So basically, JavaScript was created at Netscape, okay, which was used as a scripting tool to manipulate their websites inside the browser. And also part of their business model at Netscape was to sell web servers. And they've tried to they've created actually Livewire, which would actually render dynamic pages using server-side JavaScript. But it was not really popular until the introduction of Node.js in 2009. It was initially written by Ryan Dahl, and he criticized at the time the most popular web server was Apache HTTP server, and he didn't like the lack of concurrent connections and the sequential programming, which would be actually code that would block an entire process, right? And so he showed in 2019 that actually Node.js was a combination of the Google's V8 JavaScript engine, an event loop architecture, and a low-level I/O API. I will talk a little bit more about these guys in a few slides later. So just to give you basic numbers, Node.js is 12 years old, JavaScript is 25 years old, and the web is over 30 plus years old, right? So here I'm just showing you a timeline, so you can see that Node.js was born in 2009, Express in 2010, Koa in 2013. Also notice that in 2017, there were over 3 billion NPM downloads every week, all right? And in 2021, this year, we are running under version 16 of Node.js. Okay, so what are the main features of Node.js? Well, Node.js is single-threaded, okay? It is asynchronous and non-blocking, and it uses the event loop architecture, all right? So by single-threaded, we mean that a Node.js application actually runs in a single process, and it does not need to create a new thread for every request, okay? So it can handle thousands of concurrent connections within a single server and does not need to manage thread concurrency, okay, which could be source of bugs, right? And actually Node.js, when it performs an I/O operation like accessing a database or a file system, it does not need to block the thread, and it will actually resume the operations when the response comes back. Okay, so talking about asynchronicity and non-blocking behavior, here you have an example in pure Node.js. It's actually a web server, right? And we can see that it is using the non-blocking behavior and asynchronous behavior too, because Node.js actually provides a set of asynchronous I/O primitives that prevent actually JavaScript code from blocking. And basically all the main libraries made for Node.js, they are using the non-blocking behavior, so it kind of makes blocking behavior the exception rather than the norm, all right? Here is a more basic example of asynchronicity and non-blocking behavior. So at the top, you can see an example of synchronous and blocking code, all right? So if you see at the read file sync method, we are actually reading a file synchronously, and the function more work will run after console log, all right? And at the bottom, when you see an asynchronous and non-blocking code example, we are reading a file with the read file method asynchronously, All right, so the function more work will run before console log. So we have single threaded, we have asynchronicity and unblocking in mind. So here's a basic example of a Node.js application. Let me explain you. Actually, when you receive a request, okay, you will start parsing a URL and use some router mechanism, right? And then you will access the database, right? And then basically you will handle that data and then probably query the database again, and then finally send the response to the client. Okay, in green is that is our script. Okay, but and it's very short, right? But when you see all these IO operations when we're accessing the database, they're very long, right? And the advantage of Node.js is that basically it will split that for us. Okay, so when it receives, the first incoming request from client 1. Okay, it will parse the URL and do its job, right? And then if it needs to access the database, it will send it to the thread pool API and handle it asynchronously. So it can actually right away handle the second incoming request and so on with the third one and fourth one, right? And once the thread pool is done, it will send back data so we can handle it. And then we can send it back to the thread pool if we need it. And then the thread pool will send it back to us, and then finally we can send the response to the client. And this mechanism actually is possible thanks to the event loop, the Node.js event loop from that you can see here in this diagram, right? In the middle, you have the Node.js event loop, which is single-threaded, okay? And just think of it, that loop that is like an infinite loop, okay? Just continuously spinning. And then when you have one client, one request, one incoming request, all right, it will be handled in an event queue and handled in a first in, first out manner. And then the event loop will pick that request up, and then if it needs to send it to a blocking IO operation, it will send it to a thread pool. But it does not stop there, right? Remember, it's continuously spinning, so it will pick up again the next request, and it will continue like this. And the internal pool API will handle that task, all right? And there it will use multiple threads. And then once it is done, it will send the response back to the event loop via the callback, okay? And then the event loop will send it back to the client, all right? So this allows us to have a really high concurrency. So basically, Node.js, it's a combination of the Google's JavaScript and JVA, right? And then the event loop architecture and the thread pool API. So let's talk about web frameworks now. First, I'd like to talk about Express, and I will explain you, it's really in a really general way, basic way, their routing, their error handling, their middlewares, right? And then we're gonna talk about Koa. And when I start talking about Koa, I will be continuously comparing it with Express so we can see in an easier way their main differences, right? So Express is a fast and opinionated minimalist web framework for Node.js, okay? And the unopinionated formula, I really like it basically because it has so much low abstraction from Node.js that you feel like you're coding a native Node application, right? And that is also why many developers that start using Express are very, they can use it very fast. They learn it very fast because it has little effort to learn it, right? Here are a few numbers. It has over 18 million downloads per week, over 50,000 stars on GitHub. It was first released in 2010 by TJ Holloway-Chuck. It is actually the most popular framework and the most mature too. It's currently running under version 4. Here, as you can see, there is this is a simple setup. It's very minimalist. As you can see, very few lines of code. And here we already have a web server, and we're just basically doing a GET request, at the root, establishing an endpoint at the slash, all right? And we're using the send method from the response object to send hello world, all right? And we're listening to the port 3000. So basically, when you open a browser, you go a localhost 3000, you will see hello world, right? Here is the routing mechanism of Express. Basically, you can use all the HTTP methods like get, post, put, delete, right? And also you can, chain your different routes, so it allows you to have, to not repeat yourself. And also you can use some templating engine here. As you can see, we're setting up our application to use the templating EJS. There are many others. And instead of using the send method, we can use, we use the render method. All right, so pretty simple stuff, pretty basic. Now, let's talk about middlewares, all right, because this is interesting. Basically, middleware in Express they will be run on during the life cycle of an HTTP request. Okay, so everything that deals with an HTTP request will be done inside middlewares, right? And you have access to the request and response object, okay, and it allows you to compartmentalize your code, and you can use the same middleware for different routes, okay. And also one of the main concepts of middlewares is the continuation passing concept, which actually basically states that you can call the next middleware in the chain. And let me show you an example here. See here, we are using two middlewares, all right? You can see that in the first middleware, we are setting the status 200, all right? And then we are calling the next one with next, as you can see in the code, right? And the second middleware, we are setting the body, right? And when you use curl to request your web server, you will see the body hello from Express, and in the logs, you will see in your terminal, right? You will see setting status. So it means that the first middleware got called, and then you will see setting body. So that means the second middleware got called, right? So far so good, right? Pretty simple. And also here in Express, your error handling. If you want to pass an error to Express, you can use next, as in the example right here, and then it will be handled in a special signature middleware that has 4 arguments, and that is from Express. And then all the errors that you throw, if you want, through next, it will be handled right there. And you have to notice that actually in Express, and that is important to remember that, we will see it later, that you must use your error handlers at the end after declaring your routes and your middlewares, right? And if, for instance, you do not, if you don't have your, if you do not declare your error handler, basically Express will handle that for you. It has a built-in error handler, and it will send the static trace to the client, unless you are in a production environment. So now, let's talk about Koa. Well, Koa actually comes from the same team of Express, okay? It actually comes from the version 3, and they realized that their design was quite different, actually fundamentally different from Express, that instead of releasing a version 4, they decided to rewrite an entire library. And here, as you can see, it has over 1 million downloads per week. It has over 30,000 stars on GitHub. It was released in 2013, again, by the same team as Express. And it is currently running version 2. And apparently is cooler and harder in the framework game, right? And we'll see about that. You will be the judge of that. So here is how you set up Express, Koa, sorry. As you can see, it's like pretty minimalist tool, right? And if you compare both of them, I mean, it looks almost like the same, right? I mean, it's the same amount of lines of code, but there are actually 2 main differences that you can see here already. The first one in Koa is that it uses the async await feature, and you don't see the request and response object, you know, that you have by default in Node.js, right? Koa uses its own object, which is called the context, okay? And that is actually from their documentation. This is really one of the main differences between these 2 frameworks, because apparently Express attempts to augment Node, okay, make it better, and Koa attempts to fix and replace Node, all right? And you can see that here, for instance, when we trying to do some writing in Koa, it pretty looks exactly like the same in Express, but here you have actually to install a routing module for Koa, okay? And unlike Express, it is built in because Express attempts to, augment Node, it provides, like framework features such as routing and templating, and Koa does not, and you must install these modules, right? And it goes the same for templating, you have to install Koa views here, but actually the usage after is pretty much the same like Express, all right? In Koa, we are also using the render method. So let's talk about middleware now. I just used the same example as before as Express. We have middleware 1 and middleware 2, and the first one is setting the status and calling the next one, as you can see here, and the second middleware is setting the body, right? Basically, I mean, when we compare both, to be honest, I don't see much difference except one, and actually that difference is actually game changer for Koa. And let me show you. Express actually, their middlewares are callback based, all right? And Koa on the left here, they're actually promise based, and that's really game changer for Koa. And let me show you like some use cases, okay? First, I like to show you an example of what happens if we don't call the next middleware, okay? How these frameworks will behave, okay? So basically, the first middleware will be called, but the next one won't be called, all right? So basically, here in Express, we can see that it did not end the request, right? We'd have no response from Express server. But if you see on Koa server, it actually sends us a status 200, which is pretty cool. So big plus for Koa right there. It ends the request by itself. All right, and you will understand why. And what if, for instance, I call the second middleware but without waiting for it? Okay, so how Koa will behave? And then I see actually I just get a 200, all right? And actually that shows us that Koa will end the request once the middleware promise chain is resolved, all right? So even if you call next but you don't wait for it, it's kind of like useless. So if you call next in Koa, you must wait for it. And so one of the main advantages too for Koa is that like in Express, once you call next, you cannot do anything after, right? Because it's callback based. But if you look at Koa, Koa can do actually more stuff after they call the next middleware, right? And so just to explain you, like just to show you basically how it feels, I just found this really simple example on a Medium post. Okay, so we are going to try to see how much time it takes for a request to complete, and we will put it on an X response time header. All right, so to tell you right away, in Express it's very complex to do that, but in Koa it's so straightforward, so easy. And here's the example. We have 3 middlewares, right? The first one is setting the X response time header. Okay, the second one is setting the status. Okay, and the third one is setting the body. And so when we request our Koa server, we can see in the header the X response time that took actually 1001 ms, right? And if we look at the logs on the terminal at the bottom, right here, we see that the first middleware got called, okay? And then we see setting status, which means the second middleware got called. And then we see setting body, the third one got called. And then again, at the end, response time is 1001 ms. We see that the first middleware got called. And that is because it was the first one who started, and he was waiting for all the rest of the middlewares to resolve, and he was able to do more stuff after, right? So that's pretty cool for Koa. And same goes actually for its error handler. There you go. There, it's pretty simple too. The cool thing is that you can use try and catch, okay, which is pretty neat. And as you can see, I am waiting for all my middlewares to resolve, and then if something happens there, I will catch it, and then I will handle my error there. All right. So when you compare with Express, remember Express, it kind of goes like at the bottom, right? And you have to declare your routes and middlewares before. In Koa, it goes at the top. And then you can use try and catch, which is pretty neat. All right. Basically, because it's promise-based middleware in Koa, it will actually wrap around every subsequent middleware, so you can call them from the top, and then if one of them throws an error, you will catch it right there and handle the error properly right there. All right, so as we saw, the main differences, in Express, again, attempts to augment Node, so you feel closer to Node.js, right? And Koa attempts to fix and replace Node. Remember the context object. Express comes with some built-in routing and templating and framework features as such, right? And Koa actually is more modular. You need to install them. Remember that in Express, the middleware chain is callback based, and in Koa is promise based. And also remember that in Express, the error handling goes at the bottom, and in Koa, the error handling goes at the top. So real quick here, so a little bit of pros and cons between Express and Koa. Well, these two frameworks are very popular, okay? The community in Express is way bigger, though. So if you have an issue, something, it might be easier to find solutions in Express, and also their documentation is very good. And in Koa, though, its footprint is much lighter than Express. Express is more mature. Yes, it is more stable. The learning curve is actually easier in Express too, because you feel closer to Node.js, right? But the middleware and error handling are better managed in Koa, as we saw, because it is promise-based, right? All right, so to conclude, basically Node.js, remember, is single-threaded. It is asynchronous and unblocking, and uses the event loop architecture. All right, it's a combination of the V8 from Google Chrome, the event loop, and the thread pool API. And web frameworks for Node.js, we saw Express and Koa. We basically saw how to set them up, their routing, their error handlers, and their middlewares. And remember, the main difference is that it is promise-based in Koa, and it is callback-based in Express. That is why I put it await next. All right. That's it for me, guys. I think now Denis will be the next speaker, and he actually will be talking about he talk about really how to structure really your Node.js application. He will show you into details how to have the best structure possible for your Node.js application. Thank you.
What about now? Yep, I think I'm heard now. Perfect.
I can hear you now. That's perfect.
Yes, we can hear you now.
Thank you. Okay. No headphones, I guess. That's no problem. Okay. All right. So, Sebastien, thank you for the introduction. That was great. You put quite a lot of pressure on me to try and to show the best way to structure the application. Node.js, which is probably impossible to do, since you know, everybody has different opinions. But I'm gonna try to do it anyway. I've been using Node.js since about 2012, so hopefully I know a few stuff. All right, so Node.js projects. Let's see. Actually, I made a mistake here. I'm going to be talking about how to structure Node.js projects with TypeScript. So yeah, Node.js, but don't try to Google it. It's not a real thing. So opinionated way, right? At the beginning of the project, you'll be like asking yourself a lot of questions. Which way to go? There's so many frameworks. There's so many things to decide. How do I handle errors? How do I write middleware? Where do I put services? What is my domain? Stuff like this, right? A lot of different questions. And so if you're a beginner, it's difficult. And so this talk is more like aimed at maybe mid-level developers who've already built a few APIs, but now they're discovering that, okay, I have a few problems here and there, and I'm not sure which way to go, how to improve things, but I realize that I do have a problem, so let's find a way, right? So this way I'm suggesting here is just one of the ways to do this, and it is not for every type of application. It is not for everyone's taste, but it really worked well for us on one of the projects and a few other projects I did by myself. And it kind of allows a team to work together quite well and efficiently. So when you're making decisions for which way to go, you're always thinking about, should it be flexible or should it be quite opinionated? Should you follow convention or configuration? And you probably heard things like convention over configuration, meaning that you try not to configure things, but just try to kind of follow patterns. The other thing is declarative procedural. We have this talk before, and we kind of tend to prefer declarative approach rather than procedural. And procedural is like kind of spaghetti code, right? And then open source or in-house. So usually you should go for open source, but sometimes open source does not always satisfy you. So you kind of have to augment it with some custom in-house code. But generally, especially if you're a beginner, don't try to build your own framework. Use open source framework, learn from it, explore different frameworks, see how they work together. What's the difference between them? And then maybe you can try and build something in-house. So if we were to kind of see what to choose the left side. And if we look at all the frameworks that we have out there, I'm just listing 3 out here. So Nest.js, Next.js, they're kind of more on the left side. They're quite opinionated. They have conventions. They're more declarative. All of the 3 frameworks, they're open source. But why I put Express on the right a bit more? Because probably it's not going to be enough just to use what Express offers. It's very, very minimal. You probably have to write some kind of in-house custom code to augment it to make it better, right? So yeah. So, but yeah, before we actually start thinking how to structure an application, let me give a scope to this. We are going to talk about like server-side kind of APIs and something like this, right? So we're not going to be talking about, I don't know, let's say rendering or AI or something like this. We're just talking about APIs. Usually, so in APIs, you have an HTTP, right, layer somewhere at the top, and the users of it are just people or maybe some other servers calling your API, and you have events. They want to register user, they want to get user, create order, pay order. So it's all coming into your application, those events. Then on the other side, you have some kind of internal drivers that are calling the events. So maybe it's a cron, maybe it's a queue, can be anything, right? So the events are coming into your application, and your application has to serve them somehow, right? So for us, application is like is an event processor. All right. So what's the difference between two slides? So basically, what I'm saying here is that the events can come from different sides, and the events are just events, right? And you have use cases. But if we take a look at the calculate stats, right? The calculate stats event is coming from a cron. Let's say you want to calculate stats once a day. But then the requirement comes in from your boss, and he says, oh, I want to calculate stats on demand with a click of a button. Okay, sure, we can do that too. So let's move calculate stats at the top. We add it at the top. So actually, it's just the same thing. We want to do the same thing, but the person who generates the event, who tells that we need to calculate stats, is on the other side. But the actual processing of it is going to be the same, right? All right, so it's still an event and we need to process it. So let's take a look here. So we kind of have an application, that thing, and it seems like we can go to the same handler, which is calculate stats, from a different place. So around it, we have this infrastructure. We have the HTTP router, so we can enter from the websites or whatever, and it's called by a person, for example. And we go to calculate stats handler, and we do that. On the other side, we can call this event internally. Cron may generate this event. So this guy is the driver, right? He's driving the calculate stats handler. What's inside, those are driven. So if you know a little bit about Hex architecture, there are drivers and the drivens. And so on the outside are the drivers. All right, so let's go into serverless framework. So just as an example, serverless framework, for example, allows you to handle lots of different types of events. And if you take a look, HTTP is just one small part of those events that we have. You can consume events from S3, CloudFront, CloudWatch, Alexa, whatnot. Like events can come in, right? And all you have to do is just handle it. Here's an example of how you can set up a handler for an Alexa skill. So you say to Alexa, hello, or whatever, say good morning to me, Alexa, and it replies to you. All it does is actually Alexa calls a handler. It's not an HTTP call. It's actually internal AWS call. They do it somehow. Don't ask me, I don't know. I copied this from internet somehow, and it will call your handler. But in the end, it's just an event calling some kind of use case. So let's break it down a little bit more. But let's focus right now on HTTP because it's easier, and that's what we mostly do, right? So on the left side, we have an HTTP request coming in. Then we have this router. So normally the router is supposed to kind of transform, validate, maybe authenticate your request, and then create this request object that is specifically aimed for your application layer. So the application layer doesn't really know anything about HTTP anymore. It just has this use case. I need to do something, and this is the request. Nothing to do with HTTP anymore, just the raw data that is required for this handler. You pass it in to handler. The handler produces some response. Again, not HTTP response, just some kind of object. You pass it back to HTTP router. HTTP router does its magic, transforms it, sends it over the wire to HTTP. So we kind of want to isolate this application layer part, and we want to be able to replace the left and right side with different drivers. So maybe I can call this application layer, this use case, with some other request router. Maybe it's going to come from Alexa or Q or cron, but the middle part is not going to change. So let's take a look at simple Express.js route handler. Just like Sebastien showed us, here it is, nothing complicated, but anybody see any problem? Well, the problem is we forgot to validate our response, right? Our request. We might not have a name in the query. So we can't really, like, it's going to fail. It's not going to work properly. So let's validate first. So that's one of the most common mistakes we see often. We forget to validate our requests. You must always validate. In this example, nothing serious going to happen, but sometimes you're actually passing these values to the database and it's going to be pretty bad. So let's validate, okay. But the problem there is now, how can I actually isolate all of this into like kind of an it's still tied to a router, right? Everything is together. I cannot just take this logic and put it into like application handler. How do I do this? So like what we often see is people put all of this logic into a service layer, right? So they create another file, maybe call it hello service, and put that stuff there, they validate there, return, and just the top part is going to call that service and then return you the response, right? So this is already a big improvement, really good, but we can do better. So what I want here is that I want to kind of isolate myself completely from the router. I don't want to know anything about Express. I don't care, is it Express, is it Core, someone else, I don't care. So what I really want to do is just do my use case. I want to say hello, right? I want to produce the message. This is what really matters. I have the name, I want to produce the message. So one of the patterns I propose here, and that kind of, I think, works quite well for medium size, maybe larger size project as well, depends on your requirements, is this one. So we have a handler for your use case, and you have a clear request, you have a clear response, and then inside the handler, you just do the thing that you need to do. Let's take a look at the request. So for the request, we know we need the name. We know it must be a string. We know it must have a length from one character to 25, at least, right? And we know it comes from query. Now from query, that part is a decorator, right? So in this case, it works for our Express, but maybe we can make it work for core. It kind of can work for anything, but if it's coming, let's say, from Alexa, right? Maybe we can make from query work for Alexa as well. But we don't see the details in here. It's somewhere in the infrastructure. We isolate this part to another layer. When I'm working with this, I really don't care where it's coming from in terms of like how I'm going to get it there. I just know that it's somewhat from query, let's say. So let's see here. You can actually compose your requests, and it really all depends on you. Like one of the helpers we have, a few helpers we have here is like from params. So let's say you need to get something from a route parameter, right? It's maybe user ID. So this is how you can define it here. And I think I have a bug here. So my ID is just ID, but in the request, it's a user ID. It's supposed to be the same name. So, but because I decorated as from params, and if it was the same name, it would automatically put that param into my class, my request class. So you can have other stuff like from body, from header, and then if you're doing other crazy stuff, maybe you can have from Alexa request or from Alexa skill. I don't know. It's up to you to do this. Now, this is not open source or anything. This is just something we've done internally in the team. And it's really easy to do. You can do it. But yeah, you kind of have to get comfortable with decorators a bit. And maybe later we can release a blog post how to make this. Okay, so for the other part is you have response. And in this case, we only want to return message. But we want to be very explicit that we want to return message only and nothing else. And we're going to expose it. And I'll tell you later why we have this expose. And we will see it in future examples when we're returning some data like user data, and we don't want to expose passwords. And if we were not explicit about what we're exposing, we could expose things that we don't want to expose. So how do we actually like take this handler and put it into our router? So we need this magic function. You can call it whatever you want. We call it connect express event, right? To which you give your handler. And now the handler already has request and response classes attached to it through the decorators, right? So that connect express event, what it does, it gets the basic express route function, right? And it does the validation, it does response transformation, does your rest.json, rest.status, and so on and so on. It does that all for you automatically. You don't have to ever worry about it again. Just focus on your business cases, business rules, you know? No need to worry about little stuff like that. And then, yeah, you can of course create more those kind of helpers that can connect to different types of events. Maybe you can connect to Alexa event and you still will be able to reuse the same handler, probably, depends on use case. This is just imaginary example, but who knows, maybe you could, you know, if your this function, this magic function is able to transform the response from your handler into a response that Alexa can understand, which is, I would say, quite reasonable to say you can do this. And you can take this further, actually. So let's say you don't even want to specify the route inside the express, right? You don't even want to write router.get. Yeah, you can create yourself some helpers, some decorators like get, and then specify the route in there. And then when you pass, when you connect that handler to the router, you just kind of declaratively say, this is my handler, I want it to be routed. Get all the information for it from there. You can do this for authorization, cache. Now it's up to you whether you want to do it or not. It's completely optional. You can go crazy or maybe, yeah. So the folder structure that we get here with those three things is kind of like this. Now again, this is the way you're going to structure this is obviously up to you. You can go for different names. You can go for maybe feature-based folders where you have like users, orders, products, and then inside those users you have DTOs, handlers, routes. Inside orders you have DTOs, handlers, routes, for example, right? Or you can have this kind of root structure where you have DTOs, and inside the DTOs you have all that goes to users and orders. You know, it's completely up to you. I would suggest, like in the beginning, especially if the project is not too big, just go with this approach. Don't do feature-based because it's much more difficult to do it right, and it gets a little bit more confusing for the team. So just go with this approach because the team will understand kind of easier what to do. So what do we have here on the right side? We see that all the handlers are kind of in their own folder, and each folder has a handler, a request, and a response. Very clear, very easy to understand what's happening, and quite easy to search as well. All right, carry on. So you can also compose your responses. So sometimes you have this kind of common DTOs that you need to reuse. So maybe you have an order DTO that is used in like complete order, create order, pay order, cancel order, right? But each of those responses kind of return a little bit more. Maybe they need to add some more properties, right? But so you can extend from them. So place your order DTO into a common folder, and the rest of them are going to extend from it. All right, so we're done with the responses. So let's see, what are the common problems we see in the wild? So one of the things that we see is people tend to offload the validation of requests to your data layer. So in this case, this is a SQLize model, a very popular ORM right now, although I wouldn't suggest that you use it. So in here, you see we say, okay, we don't allow nulls. The type should be string. It should be lengths from 1 to 50, right? And then when we get the request, we just pass it in directly to that SQLize model. And what will happen is that, yes, SQLize will validate it, will produce some error. You're probably going to handle this error and return 400. Great, seems to work. However, what happens if you change the API? Maybe you change the database structure, right? A little bit. It means now your API request, your API schema is changing as well, right? So you're completely tied into your database schema. And this is probably not what you want. All your clients are going to be broken right now, right? So what we want to do, we want to try to isolate the database schema from the request schema, from the response schema, okay? They're all separate. Don't try to mix request and response, even though they might look the same. You probably want to separate them because later down the road, you will run into problems if you try to mix them. All right, another thing we see is people just returning objects straight from that database. So I get my user from database, and I just send it directly. Wow, what we can be returning is more than we expect, right? We can be returning passwords, like personal information. Yes, this is a problem. Let's not do this. So that's why we're suggesting to kind of create this response object where we explicitly say, I only want to return name, nothing else. Even if I pass it a full user object, it is going to ignore everything except take that name and return only the name. So you can add as much information. You can modify your database. You can add a lot of columns, secret stuff in there. Your responses will continue to return only what you've defined. So you are safe in this way. You're safe to refactor. You're safe to add stuff. And you're not going to break anything or expose what you don't want to expose. Right. So the other thing we see often is, okay, people already kind of understand, I don't want to put everything into my router. I don't want to put it in the handler. Let me put some stuff in the service layer. So they create this kind of singleton, bunch of singletons inside that service. They have a lot of stuff, you know, many functions. Like it's a 1,000-line file, maybe 10,000 lines. I don't know. It's doing everything. This is really difficult to work with, difficult to maintain, difficult to test, and you're really like just mixing everything together. And we'll talk about how we can fix this later. Another thing, okay, some people are like, okay, I don't want that part. I don't want to create a singleton, right? So I'm just going to kind of put create proper classes, you know, and then gonna do it right. But what they forget to do, they forget to realize that now they have to build all of those things manually by themselves, right? Still difficult to test, still difficult to maintain, a lot of boilerplate code. This is getting especially difficult when you have like dependencies of dependencies of dependencies. All right, I'm going to try to move a little bit faster, but bear with me. So another common problem we see, people try to attach things to requests, like especially in your middleware, you're trying to authenticate the user, you authenticated him, you put into request rec.user, and then later on somewhere you access him. It's difficult to type correctly if you're using TypeScript, and yes, you must be using TypeScript. Don't do Node.js without TypeScript. It's just not the right abstraction for me, at least. So what can we do? So it seems like we have this service layer kind of thing, right? So we have our router, we have handlers, and then inside there, so the handlers are calling services, right? We need a DI container to solve this. Hopefully you heard about DI container. Not sure if you use it or not, but just a quick intro into this. So what we can do, we basically can create classes and mark them to be a singleton, for example, right? So in this case, we're having a user repository. We say it's going to be a singleton. It has some kind of dependency in the constructor. Great, and it does something very specific to retrieving user information and saving that. Now we have some handler. It needs to access the user. So in its constructor, we say, we need the user repository. And that's it, right? Now, all the magic of actually giving that user repository to the handler will happen in the infrastructure layer. You don't have to worry about it. You don't have to worry about it. It will be given to you, and then you just use it. So now your folder structure is starting to look something like this. So you have services folder somewhere, repositories folder somewhere. Now again, the naming and the exact structure depends on you. This one could work. You can start with this. You can improve it later. So just put your services there, repositories there, and yeah. But we did not answer the question, how can we actually have like request scoped singleton, right? Because right now the singleton part is going to be instantiated once for like the global application. We have this user repository. Okay, everybody can use it, great. But I need actually a user just for one request, right? What do I do here? So we cannot put the user into the global container, right? Because our global container has like is used by all the requests, all the it's being used by many events at the same time, right? So I'm coming in, making request, my friend coming in, making request. We're all using the same container. So I cannot just put user there and kind of expect that it's not going to be used by others, because it's going to be used by others and we're all going to collide. So what we can do is actually, we need to create another request scope container for each request. So we do have the global DI container still, and everybody can use it. But then inside, we also have scope container for each of the requests. And then that's where we can use, where we can put user, right? And so now my request can use that user without worrying that somebody else is using it too. All right. And again, all the magic happens in the infrastructure layer. So you probably have some kind of container middleware where you use a container. In this case, we're using tsyringe. Check it out. It's a Microsoft library. So we have already a global container where you probably registered a few stuff. Then you create a child container just for this request. Yes, you put it on the request, but it's not a problem because this is infrastructure layer and your application is never going to know about this, you know. And then in your authentication middleware, you register the user, you authenticate the user, somehow get the user, and then you register the user on that specific class, right? And so how you can later take the user from the container is just by requiring him in the constructor. Now you have the user here already, he's authenticated. This constructor, this whole class will not be able to even be built, you know, be constructed without a user being in the container. So if you were not authenticated, the class can't even, you know, can't even be created. But you can still test it. You don't have to go through the middleware during the test. You can inject any user that you want. So this one is kind of a really cool way to do authentication and doing DI. But in case you don't really like this approach, there's a new way, Async Local Storage. This is a little bit of magic from Node.js, and it's now stable in version 16. It used to be called domains, but they deprecated that feature. And so now we have this Async Local Storage. The main idea here is that you can have something that looks like a global variable that you export from one file, and then you can access that variable, but you can scope it to a specific request. It's kind of sounds strange. It's like, what are you talking about? So basically we need a middleware again. And in that middleware, we request the storage, the context that we've created, which is a kind of global variable. And we put the context into that storage, and then we pass in the function, the callback that we want to run. So all the code that's happening in that callback is going to have access to your context. All the code outside of that callback will not have access to it. So each callback, because each request runs in separate callback, each request will have its own context, so its own authenticated user context. This might look a little bit like React, especially if you use the similar naming. All right, so where's the business logic, right? So we saw like we have this handler, application kind of layer, service layer, like repositories. Where's all the business logic, right? Are we going to put it into services? Yes, actually a lot of people do that. They put into services and then they have this model of like, let's say user that doesn't do anything. Right? But that's not the best way to do. Like if you want to take it further, try to do some domain-driven design and try to put more logic into your models actually. And so once you start having models, this is how your folder structure will start to look like. Yeah. So in the end, you have this infrastructure, you have handlers, services, and inside of it, it's domain. And the dependency is always going in, right? The layers from inside, they don't use the layers from the outside. So the drivers are on the outside, and they're driving the driven part that's inside. So guess I'm almost done. So there's a few more things, error handling, but I guess Seb done it. And the one thing I would say, be very deliberate about your errors. Define your errors, define classes for your errors, define error codes for your errors. Like, be very, very clear what errors you have. Don't just assume errors, right? Be very clear about your status codes and stuff like this. Then you probably need to think about some ORM. I really highly suggest you take a look at micro ORM. Forget about SQLize just for a little bit. Try micro ORM, and yeah, there's a lot of good stuff in there, like unit of work, identity map, and finally testing, right? So testing, you should usually be doing like integration tests and unit tests. But if you're like on a tight budget, have small team, don't have much resources, I would suggest you focus on integration tests first, because those will give you the most value and will be the easiest for you to write, at least in the very beginning. So that's it. Thank you. And the next speaker will be Georgii, who will take you into a REST versus GraphQL fight, which will give you kind of more things to think about. All right. Georgii.
Hello, everyone. Give a second. Hello. So I will talk about a little bit. You can see my screen already. Okay. So yeah, I will talk about how we basically access our APIs. My topic is like GraphQL versus REST API. Is it time put REST to REST? So what's REST API? I'm pretty sure that everybody of you know about what is it. So basically, it's architecture where API expose functionality with the resources, with the data, with the object, and clients can access it. So every resource basically comes with its own URL, and client can access this resource by this URL. So when client call REST API, he can use normal HTTP methods like get, post, push, patch, delete. So supports as well a lot of data format. In modern days, we mostly use JSON, and obviously for the Node.js, it's best choice to use JSON, but it supports XML, YAML as well. Let me show you example how REST API look like. It's kind of very simple example, right? With Express. Oh, okay. Yeah. All right. So we have simple Express web server here. We have part with REST API, we have part with GraphQL. Let's focus on part with REST API. We have basically two routes, restaurant and booking. So what's it? It's a system where you can book the table in restaurant. And the restaurant can show what kind of, what tables are booked for a particular restaurant and for all restaurants as well. So it's mostly look like this. So we route, we get some query parameter, and after that we pass it to service layer and just returns the values. As you see here, every route exposes his own resource. So this route's restaurant expose data about restaurants, and this route expose data about the bookings for the particular restaurant. Yeah. So it makes sense, but have some limitation, have some problem. Why basically GraphQL exists? Because of those limitations. Especially now it's mobile device era, so we really care about speed, performance, and traffic. So what's the limitation? So need to multiple requests to require all data. So what does it mean? To get booking for all restaurants, we need to request first a list of restaurants, and after that we need to request booking for this restaurant. So it's kind of, we need to do several requests to get one bunch of data. Overfetching, underfetching. So overfetching, when you request some data from API, it basically returns you everything. What if I need to load list of name of restaurants? I cannot really do it with the normal REST API. I will get all data from restaurant, all like address, like phone number, but I need only name. And underfetching, it's mean when you request some data is not enough. So, for example, for restaurant, you need to request all bookings for this restaurant, so to know which slot are available to book. And to make this, you need to do several requests, as I said. Now, where comes GraphQL? So GraphQL is query language presented by Facebook in 2012, and they make it open source in 2015. So this language enable clients to send requests and get response in special format. So GraphQL allow user to request data from several sources with one single request. And biggest advantage of GraphQL is that you can really choose what you need to request. So from restaurants, if you need only name, you can request only name. And if you need to combine several resources together, you can easily do it with GraphQL. And yeah, how GraphQL requests look like? So basically, you send HTTP post request with this format. This example I take from Wikipedia, but as you see here, he combined a lot of resources together. So basically, what we're doing here, we get in all products, name and price, and quantity from product list, and orders for this. So all list of products with all details that we need here is basically shopping cart. So what's the advantages of GraphQL? So no more overfetching and underfetching. You fetch only what you need. Queries from GraphQL are encoded in client, so client decide what data he needs. So you can build one API, and after that, make clients decide what kind of data they need. Obviously, you can fetch all required data with a single API call. And of course, it simplifies tasks to aggregating data from different sources. For example, you have some data from different database, and you need to connect it somehow. You need to put it in one request. How it look like? It's actually quite simple. As you see here in same example. I use Apollo server because it's kind of standard now for Node.js for exposing GraphQL. It simplifies a lot of stuff. So what to do basically on same web server, it will call this function. So let's create a Apollo server with some definition. Type definition and resolvers. What is type definition? It's basically a schema of your GraphQL. So all GraphQL resources present as a graph. Yes. So edges of this graph are some resources, and graphs are all edges are connected with some points. As you see here, we have booking, we have restaurant, and you see already here the H restaurant connected to booking. So it contains booking itself. And we have query. This is basically when you need to request some data, when you need to call some data from GraphQL. This is show how you call it, how you represent your request. Here as well, we use some stuff to filter in it. That's simple. And return again. You see, return one of these resources. GraphQL on this schema support only scalar. So like integer, like string. For example, here I use date, and date GraphQL not really support, but you can create your own scalar data, your own custom format data, or custom format data. So this is here, as you see here, we put it as a type definition. What is resolvers? Resolvers is kind of explain how we resolve the data from GraphQL. So you see here, same as our schema. We have query, we have restaurant, and inside the resolvers, we have query, and we have restaurant. And inside this restaurant, I write what I return, basically. It's pretty much same code as here, you see? So basically, we call service, and we just return the data. But what is the advantages? As you see here, we have resource as well. And now we explain how we resolve this resource with GraphQL. So when somebody calls in the restaurant, like here, it's return list of restaurants. So here, if somebody resolves restaurant, I explain on this, let me show in schema. We have booking. So what is bookings inside the restaurants? Oh, sorry. So what is bookings? And I explain how to resolve bookings for a particular restaurant. So what I did, I basically take parent. Parent is the restaurant here, obviously, because it's connected with the H. Take some additional parameters and just call service layer and just return particular item. So what's happening now? So when you request restaurant, for every booking, he will call this. And basically, you can combine everything in one simple request. Let me show you some example, how it looks like. So for the REST API, let me show how I create the server, and basically I create simple explanation. So what I need to do, I want to load all bookings for all restaurants, for every restaurant basically, to display, let's say on the website, I want to show what time already booked. So with REST API, as you see, I need to write quite a lot of code actually. So I need to call several APIs. So I need to get restaurant first. It's called one API. After that, for every restaurant, I need to call get booking. Yeah, this one. And after that, I combine it, and yeah, and do even after finish, I do some manipulation. But let's see how it looks like on network layer. So I call this. So okay, as you see here, this one is the request from the server. So to get this object, basically, this is our result. To get this simple object, we call so many requests, and you see we get so many unnecessary data at all. So it's just garbage data, so we don't need it. Why we like spend resources to send it? So how it look like with GraphQL? With GraphQL, we do everything in one request. Like as you see here, I even don't wrap it as any function. So what I do, I just call GraphQL. It's this URL exposed automatically by Apollo server. It's called GraphQL, and just send my request. So I want restaurant. I want name from this restaurant, and I want booking. And from bookings, I want only date. So I can show list of restaurants with dates. So how it look like? Okay. Nothing works. Why is nothing works? It is funny actually. Okay, sorry. I need to rebuild it, obviously. Okay, so now you see we actually receive only this data from the server with this request, and as you see, it's so much smaller than actual. So to get pretty much same object, we just sent one request only. All right. So what's the problem with GraphQL? If it's so good, shall we just forget about REST API? Shall we just move to GraphQL? So basically, one of the problem, because it's exposed only one URL, we lose HTTP level caching. As HTTP protocol have a lot of, and browser itself have a lot of options to cache data. You can set up everything. So sometimes you don't need, browser will not really call API if it's still having cache. With GraphQL, we lose it. Of course, Apollo server have some, and Apollo client have some options to do, but core HTTP level caching we losing when we use GraphQL. Second, I think it's much more important, performance issue with complex queries. So basically, because query get from frontend, if we request really complex stuff, if we request something too much, it will cause actually performance issues. And if it's connected directly to the data layer, as I see in many, many examples, like take it from GraphQL and from Apollo server and just put directly to database with some Squidex GraphQL or something like this, you basically have a security issue as well. So when you build GraphQL API, you need to be very careful. You need to design very carefully. So it's not about just putting GraphQL on top of database. So it creates some more complexity. You need to be careful when it's not, you need to think a little bit different, not same as when you design REST API. So difficult to monitor and handle errors. If you see this example, right, it's always return to 100. I mean, Apollo server obviously solves this problem, but if you use just normal GraphQL, it's always return to 100. it's written like 200, but inside, oh, it's server error, cannot get any data. So monitoring handle errors, it's a little bit more difficult. And obviously learning curve for developers. Because of all this one, it gets some learning curve. So switch from REST to GraphQL, you need to spend some time. So should we forget about REST? So obviously GraphQL is a powerful tool. And for some project, have many options to choose GraphQL. But for most of projects, still, I think REST is best choice, especially when you like care about low performance. You need to think about complexity. I mean, REST API is still a good option. So I mean, every technology have his use cases. This one obviously very good for Facebook. That's why they created it, obviously, because they need to separate data. And for some use cases, for some application, this can be really useful. And as you see, for developers, it's kind of with little bit learning, you can easily apply it. So that's it. If you have any questions, please ask. I'm done. I wait a little bit. All right. Okay, guys. So thank you for coming.
Sorry, Georgii. We have a question
Yes.
for Sebastien.
Yes.
Yes. Okay. Sebastien, are you here? Still here?
Yes, I'm here.
Okay. So there's a question from Wichai.
Yes. I saw the question. So the question was, does that mean multi-threading, like worker threads, is actually sugar-coated asynchronous single thread achieved with an event loop? It's an interesting way of seeing it, but we have to keep in mind that in Node.js, the main advantage and the main purpose of Node.js was to achieve high concurrency. So basically, the multi-threading part that we talked about in the general example of the diagram of the Node.js event loop is handled. The multi-threading is handled by the thread pool API, which is developed in libov, which is a multi-platform C library, right? So yes, the Node.js event needs to be single-threaded, and in reality, there are really a really small number of threads for the event loop, but the main point is to achieve high concurrency. I hope that helps to answer the question.
Okay, does any other question, anyone? Our speakers will be happy to answer all your questions. Okay, I think that's cover all. If there's no one gonna ask any other question, we will close this webinar. Thank you for those who coming. We hope to see you again in the next event. See you. Bye-bye.